Speech-to-speech is a low-latency, fully modular voice agent pipeline that chains together voice activity detection, speech-to-text, a language model, and text-to-speech. Each step runs in its own thread and communicates through queues, so you can swap in any backend you like. The LLM slot speaks OpenAI-compatible protocols, letting you use a hosted provider, an HF inference server, or a locally hosted LLM such as VLLM or Llama CPP. This pipeline powers many Riachi Mini robots in production. Building a quick start is easy. Install the package with pip, set your OpenAI API key, and run the server. It will start a server at WS localhost 8765/v1/realtime that speaks the OpenAI real-time protocol. Behind the scenes it uses Parakeet TDT for local speech-to-text, an OpenAI-compatible LLM, and Qwen3 TDS for local speech output. If you prefer to host the LLM yourself, you can spin up a Llama CPP server with Gemma 4 and point the speech-to-speech server at it with the appropriate flags. Any OpenAI real-time-compatible client can connect. The library ships with supported components for voice activity detection, speech-to-text, language models, and text-to-speech. For VAD it uses Solero VAD v5. For SDT it defaults to Parakeet TDT but also supports Whisper, Faster Whisper, Lightning Whisper, and Paraformer. For LLMs you can use the OpenAI Responses API, the Chat Completions Endpoint, Local Transformers Models, or MLXLM on Apple Silicon. For TDS the defaults are Qwen3 TDS, but you can also use Kokoro 82M, Pocket TDS, Chat TTS, or MMS TDS. The pipeline supports several run modes. The default is real-time, exposing a WebSocket endpoint that implements the OpenAI real-time protocol. You can also run it locally, in which case the microphone and speakers on your machine directly feed the pipeline. For custom clients you can use a ROT-PCM WebSocket or a ROT-PCM TCP socket. Docker helps deploy a configuration with a Llama CPP server and a socket server, exposing ports for the local and remote communication. The real-time API uses a WebSocket that streams audio and connects over the OpenAI real-time protocol. A client can send a session update event to configure turn detection, then feed raw audio. The server emits events such as input audio buffer append, session update, conversation item create, response cancel, and give streamed audio back. The full event set is documented in the repository's real-time engine README. When choosing a LLM backend, keep in mind that it is the most compute-intensive part of the pipeline. A single forward pass can dominate end-to-end latency. The library supports local inference with transformers or MLXLM, self-hosted servers like VLLM or Llama CPP, and provider APIs such as OpenAI, HF inference providers, or OpenRouter. Two API backends, ResponsSP and Chat Completions, share the same connection flags. The ResponsSP backend targets the v1/responses endpoint, while Chat Completions targets v1/chat completions. You can also disable reasoning on providers that ignore the chat template coorgs by adding a reasoning effort flag. For fully local setups you can run a DDA-CPP process serving Gemma 4 and point the speech-to-speech server at it via the ResponsSP backend. This gives a low-friction local deployment. Language coverage depends on the backends you pick. Parakeet TDT supports around 25 European languages. Whisper and its variants cover many more. Qwen3 TDS is multilingual by default. Kokoro, Chat TTS, and MMS TDS each support multiple languages depending on their checkpoints. To use a single language, set the language flag. For automatic switching, set language auto and optionally enable a prompt that tells the LLM to reply in the detected language. Pocket TDS, a lightweight stream-based TDS from Coyote Labs, can clone voices. A small set of preset voices is provided, but you can also use custom voice files or Hugging Face paths. The CLI is highly configurable. Common options include device selection, run mode, backend choices, and logging level. VAD parameters let you tune the threshold, minimum speech duration, and silence length. SDT, LLM, and TDS parameters allow you to specify model names, device placement, and generation settings such as temperature and maximum token counts. The full set of arguments is available by running speech-to-speech H. If you deploy this pipeline, please cite the component models you are using. The default components are Solero VAD, Parakeet TDT, Qwen3 TDS, and the chosen LLM backends. Documentation for optional backends such as Kokoro, Pocket TDS, and ChatTTS is available in their respective README files.